In this video, we will be learning about the different instruction types with the help of some sample instructions. Also, how the sequencing will be done, is being done, and different forms of sequencing while executing these instructions. So, recollecting the things from the previous class, different types of instructions are like 3 address instruction, 2 address instruction, 1 address and 0 address instruction. It will be based on the number of operands. So here for 3 address instruction will be like an operation field followed by the operands. It will be having 3 operands, and in which data will be data will be stored in some address, and it will be fetched from the memory. So add A comma B comma C, it indicates that, which means that operands from A and B will be added and the result will be stored in C. So this is the register transfer notation. Or here one more thing that you need to keep in mind is, for register transfer notation, you need to enclose the variables within the square bracket. Enclose the variables within the square bracket so that the content of A and B you will be getting. Similar is the case with the 2 address instruction. The operand field will be having addresses of that is 2 addresses, and 2 operands it will be having. And in case of 1 address instruction, it will be having only 1 address, and the second operand will be considered to be as the accumulator. Okay, for example, add B. Here AC accumulator indicates the accumulator value, so AC plus content of B register with respect to this instruction. Okay, so here AC it is taken it is given implicitly and need not be specified in the instruction. So such form of instruction which will be having 1 operand, then that instructions comes under the category 1 address instruction. Then 0 address instruction is like it will not be having any operands. Instead, the operation code will be specified, and it can be applied on the push down stack. So the operation performed will be like, if an add instruction is given, then the top of the stack will be loaded with the current top of the stack plus the top of the stack minus 1. That is top of the stack plus content that is below it, the top of the stack minus 1. If the stack considered is arranged in such a way that the addresses it grows upwards. Okay, so while performing this operation, popping of 2 numbers will be done. Perform the addition operation of those 2 numbers that is being popped, and push the result onto the stack. So this is the instructions that is being given, and each instruction explanation also it is given in this description part. Then now considering the examples, so here we are considering a statement like A plus B into C plus D. It is a form of expression, and the result after evaluating, the result need to be stored in the X memory location. Okay, so for this expression to evaluate, you need to write the 3 address instruction, 2 address, 1 address and 0 address instruction. So here 3 operations are performed, that is A plus B, 1 addition is there, C plus D, second addition, and result of those 2 expressions will be multiplied. So for that, in case of 3 address instruction, first you can just use the opcode followed with the operands, that is A and B, that is given in the expression itself, and the result you can store it in one register so that the result can be used later. So making use of this instruction means that R1 will be stored with the added content of A and B. Then second operation is C plus D. For that instruction also you can write in the similar way, like add C comma D, and the result will be stored in register R2. Then the next is like currently the R1 and R2 is having the result of those two addition operations, and the result that is stored in R1 and R2 need to be multiplied. So for that, operation code used is MUL, multiplied, and the result will be stored in X. Okay, so this is the way you will be writing the instruction, and its corresponding register transfer notation is also mentioned in the right hand side. Now same equation, if you need to write using two address instruction format, then it will be written like this, like starting with only two operand fields you need to write. In such a case, each value need to be loaded to the register. That is, in case of A plus B, first value it will be loaded to the register. Either A or B can be loaded, and add B comma R1. Second operand is added to the R1 value. So in such a case, what happens? The result will be stored in R1. Then again move C comma R2. For the second operation, C plus D, move C comma R2. Then add D comma R2. Perform the addition operation. Then result currently it is stored in this R1 and R2. Perform the multiplication operation using the opcode mul. Now the result it will be stored in R1 register. Now what is the final thing that it need to be done? The final result it should be stored in the X location. So for that, move instruction again it will be used. Now the final result is stored in here, it is stored in R1. So this R1 value will be moved to the location X. Okay, so in all these instructions only two operands it is being mentioned. So this is the way you will be representing the two address instruction. One memory and the other one will be considered to be as the register. The previous example, two memory addresses and one register value, register location is specified. Then comes the one address instruction. So in this case, again it will be making use of the accumulator implicitly. So the operation instruction can be like load A means that the value of A is loaded to the accumulator, and then add B is like value of B is added with the accumulator content, and the result will be again stored to AC. So now the result after adding A plus B is currently available in AC. Now this AC need to be again used in order to store the result of C plus D also. So it is just for a temporary storage. It need to be loaded elsewhere so that the result can be obtained later. So for that we are making use of another location, that is T, another variable making you are considering. So what you are doing here is the accumulator value will be returned back to the memory. So in order to write it to the memory, we will be making use of the store instruction. Okay, or else what you need to do, you need to make use of move alone. For load as well as store, you need to move you need to use move instruction, MOV instruction you need to make use of. So in such a case, to that temporary, that is to that memory location T, the value currently loaded in accumulator will be written or stored. Now what is the next step? It will be doing the operation instruction for C plus D, like load C. So C value will be loaded to the accumulator, add D, then D will be added to the accumulator value, result will be stored in accumulator. Now mul T, which means that current AC value is having the second result obtained after performing the addition of C plus D, that is present in AC, and the first result is present in the memory location T. So in such case you can just give mul T, which means that T is one operand, and current value from AC will be taken, perform the multiplication operation and gives the result which is stored in the AC. Now what is the next task? We need to store the result in memory location X. So for that again store X will be used. Okay, so X to X value, to X location, the current accumulator, that is the final result stored in accumulator, will be written. Then next final one is zero address instruction. It makes use of the push down stack. So in such case what happens? First A will be pushed into the stack. A will be pushed into the stack. Then B will be pushed into the stack. So push A and push B will be used. Then perform addition operation means currently it will be pointing to the top of the stack, that is B. So add means like B and A will be pop, perform addition, and you will be getting the result as A plus B in the top of the stack. Then what you need to do? Again C plus D calculation will be done. So what is the instruction that will be written? You need to push C and then push D. Again add will be called. Push C and push D. Again add will be called. In such a case what happens? Current top of the stack will be added with the previous content. After popping that is by popping the elements, this addition operation also will be done. So the current top of stack will be loaded with the result C plus D, and next instruction that is given as mul, which means that current top of stack is the result that is stored C plus D minus 1, that is top of stack minus 1, it is pointing to A plus B. The two things gets multiplied and the result will be final result, that is this equation. The result of this equation will be stored here. Okay, so this is the way we will be writing the instruction for the zero address instruction. Now the what is the final answer need to be copied to the X memory location. So for that, current top of top of the stack need to be popped in order to store to the memory location X. So for that pop X will be given. So this is the way we will be writing the instructions. So here we can see that for each instructions, in case of 3 address, 2 address, we will be making use of registers also. The purpose is like while using the registers, the time to fetch the data from the memory will be reduced. Okay, that is the time that is incurred in order to execute the instruction, it gets reduced, because already 2 operands, in case of 3 address instruction, 2 operands need to be fetched from memory. So the third operand, instead of fetching from the memory, it can be obtained from the register. Also the number of bytes that is used to represent that instruction also, it will be less if we make use of the registers. Okay, so the number of registers is smaller. So 32 registers means it is these registers can be represented using 5 bits, but that is not the case with the memory addresses. It requires more number of bits to represent each memory location. So it is better that for 3 address instruction or 2 address instruction, one can be included as a register. then it speeds up the operation.